Hello and welcome to the new lecture session. Students, today we will discuss on a new topic, that is liquid penetrant testing. This is the widely used methods for the testing of NDT or non-destructive testing. So let's start the liquid penetrant testing. This is the oldest and most widely used non-destructive testing methods. This penetration inspection utilizes the natural accumulation of a fluid around a discontinuity to create a recognizable indication of a crack or other surface opening defect. Capillary action attracts the fluid to the discontinuity as compared to its surroundings. In order to locate the area, the excess fluid, the background area must be sufficient contrast, thus leading to distinct detection of the defect on the surface. So this is basically used to reveal surface breaking flaw by bleed out of a colored or fluorescent dye from the flaw. This is known as dye penetrant inspection. This is applied to most of the material, including metallic and non-metallic objects. In the maximum production house, where different kinds of material product that may be used metal for the production, or they can be used non-metal for the production. So in every cases, metallic and non-metallic object, this is the most applied method to find out the is there any defect or any crack or flaws are present or not. So basically metallic material such as aluminium, magnesium, titanium, cast iron, stainless steel, powdered metal product, copper, brass, bronze, etc. So any kind of metallic material can be tested by these methods. And beside the metallic material, non-metallic materials such as ceramics, plastics, molded rubber, composites, glass, etc. So beside the metallic material, non-metallic material also be checked for the quality check. This is the method which is basically used. So penetrant testing cannot be applied on a porous surface. So this is the main disadvantage, that this penetrant testing cannot apply on the porous surface. Porous surface means which is allow the passing through of water, liquid or vapor. Objects containing porous surface have empty space or pores that allow external matter. That's why, so just because of that, there is no medium or there is no solid medium, so we cannot use. So in a single line, if we want to say in a single line, so that can be that is the liquid penetration testing can be used any kind of solid material, that may be metallic or that may be non-metallic material. So this is the basic definition of basic things on the liquid penetration. Let's come to the history. In the year 90s, to defect crack in locomotive parts, firstly, this method is invented. At that time, oil and whiting methods are basically used. In 1940s, fluorescent and visible dye was added to the oil to identify the flaw in easily. So, in 90s, to defect locomotive part crack, so this oil and whiting method had been invented, and in 1940s in the oil there are some fluorescent or visible dyes was added to easily identify the flaw on the from the material. So this is the history of the liquid penetration. Now comes to the working principle. Penetration inspection basically depends mainly on the ability of liquid to wet the surface of a solid workpiece or specimen and flow over the surface to form a continuous and reasonably uniform coating, thus penetrating into cavities are there that are open to the surface. The ability of a given liquid to flow over a surface and enter surface cavities mainly depends on the surface tension and the capillary action. So students, just because of two things, one is surface tension and second one is capillary action, the liquid which is applied on the which is used to find out the crack which is entered into the cavities. The cohesive force between the molecules of a liquid causes surface tension. The cohesive force between the two molecules of a liquid causes the surface tension. And the capillary action, which is the phenomenon of rise or depression of liquid. This is a phenomenon of rise or depression of liquid in narrow cavities. Viscosity, another factor, although was negligible effect on the penetrating ability of liquid. Affect the flowing ability of penetrant. Very viscous liquids are unsuitable as penetrant because they do not flow rapidly enough over the surface of a workpiece. Consequently, they require excessive long periods of time to penetrate into the fine floors. Visible light or ultraviolet light is required. Visible light and ultraviolet light is required for inspection of penetrant indication. Initially, the only detection method was the unaided observation by the eye of the inspector under the visible light. The characteristics of human eye strongly affect the perception of brightness of an indication. The nature of light source strongly affects the perceived brightness of the colored region being observed. Thus, it is important to have the proper lighting at the inspection area. Fluorescence describe the release of light energy by some substances when They are excited by external radiation such as ultraviolet light. In penetrant inspection, when the particles in fluid are struck by the incident ultraviolet light, they are excited to a higher energy level. After being excited, each particle then returns to the original unexcited level, with the emission of light having a wavelength longer than the original source. Thus, the emitted light is in the visible spectrum because the UV or ultraviolet light is not normally seen by the human eye. It is also called black light. The advantage of this in penetrant inspection is that region holding greater amount of the fluorescent penetrant appear very bright. Then the inspection is performed in very subdued light. The regions clear of penetrant material will appear black. Due to this effect, the visibility of small indication is greatly enhanced. A significant improvement in both the reliability and sensitivity of penetrant inspection occurred with the introduction of laser scanning devices that are able to automatically scan large area. Laser being monochronic light source, excitation by laser show defect indication distinctly both in form and the color. So use of laser scanner, however, is confined currently to laboratory testing and not yet become applicable to in situ inspection of components in plants. So basically, what are the main points on this working principle? That is, these methods depends mainly on the ability of the liquid. The liquid which helps to wet the surface of a solid workpiece or the specimen, and then the liquid flow over the surface to form a discontinuous uniform coating, penetrating into cavities that are open to the surface. The ability of a given liquid to flow over a surface and the flow and the liquid enter the surface cavity mainly depends on this surface tension and the capillary action. The visible light and UV or ultraviolet light is required for the inspection of penetrant indication, which is easily helpful for the human eye. After the working principle, now comes to the procedure. So students, there are the 7 points are there which is important for this procedure of the LPT, liquid penetration testing. Number 1 is clean the test object. Number 2 is dry the test object. Number 3 is apply penetrant. Number 4, remove excess penetrant. Number 7, apply developer. Number 6 is inspection and evaluate, and number 7 is most clean test object. So here in the figure you can show A, open defect, B, penetrant in crack, C, excess penetrant clean from the surface, D, broadened width of penetrant due to the developer, and C, crack detection by the visual inspection. So basically this is the procedure. Now elaborate these things. First one is cleaning. Clean the test object or cleaning. One of the most important step in the penetration inspection procedure is the initially cleaning on the surface area which is to be inspected. The defect that is being sought must be open to the surface for the penetrant to enter. If there are some dust particle or any dirtiness or dust particle be present on the uh, crack push on the crack, so you cannot find out the flow from the specimen. So first, that's why we need to clean the surface properly. Then after the cleaning we need to dry this object. That's because if we use some oil or whatever, though for this purpose, after cleaning the surface, for the cleaning purpose we use anything. We use some chemicals or some anything. So after the apply to clean the object, we need the specimen for to dry. After the dryness, apply the penetrant. So basically this is the second step. So here, inspection process in the application of penetrant fluid to clean the surface. The fluid should spread freely and evenly over the surface and move into crack. The dwell time, which is the amount of time required for the penetrant to move into the crack, will vary depending on the crack size and shape characteristics, and also the environmental condition such as temperature and surface inclination. Application of penetrant may be achieved by dipping the component in the bath of penetrant liquid or by spraying or brushing. A minimum dwell time of about 20 to 30 minutes may be allowed after penetrant application. After this penetrant, so we need remove the excess penetrant. So this is the most important step in the entire process. The desired result is that the surface is completely clear of penetrant, yet the crack and defect retain on all the penetrant that are enter into it. Excess cleaning may remove the penetrant from the upper region of the defect, with the result that the developer does not reach the penetrant and no defect is indicated. On the other hand, insufficient cleaning will leave a background of penetrant on the surface. Due to this, the defect will appear only slightly different from the background area. So this difference is contrast may not be sufficient for the defect to be recognized. Thus, care must be exercised so that either insufficient cleaning or over cleaning is done. After the cleaning, apply developer. After removing the excess penetrant, a thin coating of developer is applied. A thin coating of developer is applied over the surface to draw the penetrant out of the crack and increase its visibility. After this, apply the developer. Next is inspection and evaluate. Basically this is the last step. So here process is scanning of surface and for the indication. The scanning may be carried out under visible light condition or with the ultraviolet light, and the defect recognized may be made with a human eye or with automated optical scanner. After identification and evaluate the crack, next clean the objects. So basically this is the procedure of the liquid penetration test. For the testing we use these 5 material. One is penetrant, second one is cleaner and emulsifier, third one is developer, fourth one is special requirement, and the last one is test blocks. In this picture basically there are the things. This is the cleaner or remover, this is the penetrant, and this is the developer. This is the use for this method. So let's start with the penetrants. The penetrants material consist of the indicating dye plus the carrier fluid. The indicating dye may give a color contrast with respect to the surrounding, as is the case for visible dye penetration method, or a brightness contrast for the fluorescent dye penetrant. For visible light penetration, the dye is usually red in color. For the visible light penetrant, dye color is red, and for the fluorescent penetration, the dye color is yellow green. Yellow green under the ultraviolet light. One of the significant factors in the choice of penetrant material is the detection sensitivity. From the experimental results, it has been found that the highest sensitivity achievable is with the water washable or post emulsifier system. So this is the basic thing of. So for the penetration we use they must need some property which is for the good penetration, that is capillary, viscosity, surface tension, cohesiveness and adhesiveness, specific gravity, non-flammable, volatility and removability. So these properties are required for a penetration is good condition. Is any of this not there, so penetration is not in the good. So each of them must be required. Next is the characteristics of the good penetrator. So penetrators spread easily over the surface, which is the penetrance which is easily drawn into discontinuity by the capillary action. This penetration is not to be harmful to the inspector or the material during the testing. It possesses high indicating capability, remain in fluid state, possesses less dwell time. It is not to affect the physical and the chemical properties of the specimen. It has cohesive and adhesive and relatively low in cost. So these are the main which is required for a good characteristics of a penetration. So class so students, in the next day we will discuss the later thing, the rest of the thing which is required for the testing penetration testing material, that is cleaner, emulsifier, developer, special requirement and testing block. So okay, Thank you, class. Thank you so much.